We can also see that many real-life scenarios can be represented by a pattern of numbers which exhibits arithmetic decay or arithmetic depreciation. A printing press was bought in the year 1992. It depreciates in value by the same amount each year. That'd be our D value. 5 years after it was bought, the printing press had a value of $311,000. It had a scrap value of $2,900 in the year 2010. Use an arithmetic sequence to determine the amount of the annual depreciation. It's a fancy way of saying solve for D. So if I say that I'm going to let Tn be the value in years after 1992, then I would say that T5, 5 years after it was purchased, it was $311,000. If it was purchased in 1992 and it was scrapped in the year 2010, then 18 years passed before it was scrapped. If that's true, then I can say that the common difference would equal 2,900 minus 311,000 divided by 18 minus 5. Which means that 308,100 is how much it changed by in 13 changes. Sorry, negative 308,000. Which means that it's going down by $23,700 each year. And then I can state that the annual depreciation is $23,700. When it says determine the purchase price of the printing press, then if after 5 years, or in 1997, it was worth $311,000, I can use this to work backwards to find what it was in the first year. I'm going to say that 311,000 was equal to my first year. Let's just call it A for right now, because it would actually be term 0 in this case. And then I'm going to add to that, 5 years had passed, and it was going down by $23,700 every single year. which means that my A value, or initial value, would be 311,000 minus 5 times negative 23,700, or $429,500. Now, the key here to remember is that we said it was 5 years after it was purchased, which meant there was actually 5 changes, not 5 minus 1 changes. This is the most common mistake that happens with these ones, depending on how you create your problem. If I'm relating arithmetic sequences to linear functions, a pile of bricks is arranged in rows. There are 28 bricks in the first row, and the number of bricks in each row is 2 more than in the previous one, which means that in row 1, there was 28. In row 2, there would be 30. Row 3, there would be 32. 4 would be 34. 5 would be 36. 6 would be 38. 7 would be 40, 8 is 42, 9 is 44, and 10 is 46. Now, on the graph here, each tick is going to make up 2 lines. So I'm going to start at 1 and 28, 2 and 30, and then it's just going to create this linear relation that's going to keep going up, just like this, all the way up to 10 and 44. We know that all arithmetic relations are always going to be linear. Determine if the range is an arithmetic sequence. The range is an arithmetic sequence with a T1 of 28 and a common difference of 2. What is the domain in the relationship? Well, the domain in this case is represented by R, where 1 is less than or equal to R, which in this case went up to 10, where R is an element of natural numbers. Why does the graph not have an intercept on the vertical axis? We can't have term 0. Or we're not going to have a row 0 that happens to have 26 bricks in it. remembering that, like we said up here, the domain is only going to be natural numbers, and natural numbers don't include 0. Last but not least, if we create an equation for the number of bricks in the row, then we're going to say that if Tn is equal to term 1 plus n minus 1 times d, then Tn is going to equal 28 plus n minus 1 times 2. But we need to remember that in our formula, n was still n, but that is representing my term value. So I need to replace Tn with just n. R represented my row number, which is my x value in here. Which is going to replace my n in my general formula. And like with any of the cases, if I wanted to, I could simplify this formula by multiplying the 2 into both parts here and combine the like terms to state that n could also be represented as 2r plus 26, which fits into our linear equation form, y is equal to mx plus b. We can see that we would have that initial value of 26 if it actually did cross the x or the y axis, and it has a slope of 2. Go ahead and try some practice.